Little job to do here, which unfortunately is going to be a bit more blooming awkward than you'd think it should be. This is a Ducati Cylinder Head. It's had some repairs, so it looks like it had been, not quite sure why. It's had some welding in this area, and then they've smoothed it all down but overdone the smoothing, so consequently this kind of annular surface here is not flat. There's a bit of a dip going on here. So our job is to try and machine this. Now, two approaches to this. It could either be done on a mill, and I've seen somebody do something similar with the job set on a rotary table, and as they turned it, the milling cutter just went round. Not ideal, I'd have thought, because of the pattern of machining marks that you're going to get left. Nicer by far would surely be to turn it. Of course, you could do it on a milling machine if you had a facing boring head, like a Volhaupter or something like that, which I don't have. So this has got to go on a lathe. And to mount it on a lathe, if you was going to mount it on a mill, you'd have the same difficulty, because it's obviously got to be this way up. Bolting it down onto something is going to be a bit awkward, because it's not flat on the other side, and even if this hadn't had a repair, it would have still not been flat. So we've got to sit it down on top of these machine parts here, which I have checked with a height gauge. We'll just set that on the table, so that's level, and if we get the height gauge over, we can check that these are all the same height. So if we can sit it down on top of this, we should be able to get it level this way up in order to machine it. This is an old school hand taper tap. So we've just started it with it in the drill chuck, and now we need a bit of leverage, and we do the old fashioned, well, once we get down a little way, we'll go half a turn forward, quarter of a turn back. Well, yeah, and then it's really 3/4 of a turn forward, isn't it? quarter of a turn back. Yeah, you know, breaking the swarf as it comes off the flutes of the tap. Nice to use machine taps where you can just screw them straight in, but this being 5/16 Whitworth, because that's the size of the bolts that I found, and the only tap I had, well no, I've got two taps, a taper tap and a bottoming tap, so yeah, that's why we're doing it like this. And it's getting a bit easier as it's breaking out the bottom. Right, I've just made up 4 little steel spacers, ground the surface on one side so that they're all the same thickness, and they are ready to screw into our what are we calling this thing that we're making? A fixture plate. Right, what I could do with now is a really long Allen key so that I can tighten these bolts up. I had to slacken them off a little bit just to be able to get that on there. I suspect if I take this off and tighten the bolts up, it probably won't go back on. No, doesn't quite wanna. So, I mean, the heads of these bolts are pretty good fit in the holes in the head. The heads of the Allen bolts are good fit in the holes in the cylinder head. And obviously, where I'm tightening these up, these are just tweaking a little bit out of position. just enough for it to not want to go on. So yeah, ideally I want to slacken these off a smidge. Drop the head on. Come on. There. And now tighten the bolts up. Have I got a long enough Allen key? Let's have a look. Well, yeah, we've got a long enough Allen key. It's a ball-ended one though, so I don't want to be tightening it up too much. But then I don't think I need it to be mega tight in any case. So, come on. Get in the hole. There we go. Huh. It's not going to get there. Well, it is. I was going to have to move the head over, but that's okay. Right. That one, yep. Right. Dare I take that off again? But it's located. All I need now is something to actually hold it on. Right, next step. I'm not going to disturb. Oh, I'm going to have to disturb that to sort out the bolts that I'm going to use to fix the head onto this plate. But yeah, okay. Let's see if they'll come off. No, it won't. Okay. I think these bolts, the heads of these bolts, are acting as kind of like cam locks, because they're obviously not quite concentric to the thread of the bolt. I think that's usually the case. As you turn them, they just move over a little bit. So we'll just slacken these off a bit again. Oh, really? But so far, looks like the plan is going to work. I've just drilled and tapped another 2 holes in this fixture plate, just there and there, and we're mixing and matching the imperial and the metric, because those two are M10, and you'll see what they're for in a bit. Right, this goes on here. Oh well, that's actually loose now. But when I nip up these bolts, I believe it's going to not be loose. So now we have this piece, which goes in here. and we have a 10mm bolt which is going to go through this hole, which we can't get in with that straight, so that's got to go in there, and then that can go around like so. And then on the other side, we have this piece which goes over there, and on this side luckily we have room to drop a bolt in through there. And those two bolts, the Allen bolt on this side, because there's only room for a socket cap, and the hexagon bolt on this side. The pair of those are going to hold this head to the fixture plate. And now we're going to put the whole caboodle in a 4-jaw chuck. Well, the clock is showing up a bit of variation on this surface here, and it pretty much corresponds to what the problem was, where this cylinder head it's been repaired. It's had some welding here, and then afterwards it's been smoothed off, and they've taken too much off where the weld was. So that's pretty much what we're getting on this clock. I don't know if we can actually see this. So that's the high point there, which is on, yeah, that's on the inlet side. Confusing me for a minute. Yeah, that's the inlet bolt, or just above the valve seat, and that's a high point. And that's fairly steady from here round to here, and then that drops above the exhaust seat and then comes back up again, not quite as much, and then creeps up a bit to where it was to start with. So I've tried tapping this back in the chuck, and it's pretty much where it's going to be. That is pretty much solid in there. So I think all we can do now is actually spin this up and take a skim. Well, I'd cleaned the engineer's blue off of this before I put it on here, and I didn't want the blue on there when I was running the indicator on it, but I'm just going to put some marker pen on this bit so that we can see when we're down to the low spot. Well, I don't know if we were getting some vibration coming through to the camera there. It looks a bit weird, this thing spinning around. It seems fairly well balanced, so it's not... doesn't seem to be generating too much vibration, but yeah, I'm not sure if we're getting a bit of something coming through to the camera, which is attached to the lathe. We're only spinning it at 140 RPM. I think that's fast enough. We're taking the tiniest amount off. I've just taken just touched on basically at the minute, and I think we're only going to be taking about 10 thou off of this. So right, let's carry on. Interesting. Cleaned up near the edge more than it has at the back, so we're nearly there. Tiniest bit left. Oh. Well, I think that might be it. There's a couple of tiny little pinholes in the edge of at the edge of the weld in there. I don't really want to take any more metal off than I really need to. So, and the point of the exercise is basically to make this flat so that it seals on the barrel. I think that's maybe done.